All right, at this point you should have attempted the warm-up, so go ahead and listen through to check your answers and see if you had any confusion. So we're determining all the values of theta, which is going to be our angle measures in radians, over the interval from 0 to 2 pi, where 2 is less than or equal to theta, and theta is less than 2 pi, so 2 pi will not be included. So looking at this, we say cosine is x, and I'm going to ask myself what reference angle has a cosine of 1/2. Well, that's going to be pi over 3, and we know that we have a negative x in quadrants 2 and 3. So I'm going to sketch my quadrants here. We know that it'll be in quadrant 2 and 3, meaning that it'll be furthest from the x-axis. So one of our angles will be at 2 pi over 3. And then to account for quadrant 3, the other angle furthest from the x-axis will be 4 pi over 3. So our solution is theta equals 2 pi over 3 or 4 pi over 3. All right, our next one is sine of theta equals -1. So we know that sine is y, and it's going to be a -y. Well, there's no reference angle in terms of having a y value of -1. It's going to end up being a quadrantal. So I like to sketch it out here. At 90, our y value is +1, so our only option here is at 3 pi over 2 because you have a y value of -1. So theta, there's only one solution, equals 3 pi over 2. All right, and then lastly here, we're going to check cotangent. So cotangent is x over y. And it's important to know, okay, anything that has a tangent and cotangent, so it's always kind of the reciprocal. So I know that the reciprocal of this is tangent of theta, which would be -√3 over 3. When we have a tangent that has -√3 over 3, or just √3 over 3, we know that our reference angle is going to be pi over 6. We also know that tangent is negative in quadrants 2 and 4. So if we sketch this, in quadrant 2, our angle that is closest to the x-axis is at 5 pi over 6. So theta will equal 5 pi over 6, or we now have to account for quadrant 4. And that angle is located at 11 pi over 6. All right, now again, we're determining all the values of theta, so angle measures in radians, over the interval from negative, that's bigger here, 2 pi to 0. So theta will be greater than or equal to -2 pi, but less than 0. So if we look here, we know cosine is x. And our reference angle, same things as above, is pi over 3, and that we normally have negative cosines in quadrant 2 and 3. But now, looking back, it's a different interval. We're saying from -2 pi to 0. So if we think about this, at 2 pi over 3, if it was positive, it would reflect or if I made it negative, it would reflect into the third quadrant. So technically, this is negative 2 pi over 3. Okay, that satisfies the interval, so we know that it's in quadrant 3, and it has a reference angle of pi over 3, so negative 2 pi over 3 will be one of our solutions. Now, if we think about it normally, I'll draw a separate one. If we saw above, in quadrant 3, our angle was 4 pi over 3. But if we make that negative, it'll get reflected into quadrant 2 and also satisfy what we're looking for theta. Both of these intervals fall between negative 2 pi and 0. Now, same things again as above. We have a sign value. We're trying to make it negative 1. So if we take a look here, if it has to be between 0 and negative 2 pi, well, 3 pi over 2 is not between that interval. So if we look here, if this is pi over 2, we know that here would be negative pi over 2, so that's satisfying that interval above. So theta will equal negative pi over 2. All right, and then lastly, again, all the same things for cotangent, so I'm going to copy it over. Except now we're satisfying the interval of negative 2 pi to 0. So instead of saying that this is 11 pi over 6, we know that if this is pi over 6, if we reflect it over the x-axis, negative pi over 6 would be in the same location. So one of our solutions for theta is negative pi over 6. Now similarly to in quadrant 2, well, the 5 pi over 6 isn't going to work anymore. But if we need something to get reflected into quadrant 2, we know that this is 7 pi over 6, meaning that this would be negative 7 pi over 6, which satisfies the interval that we're trying to uphold. All right, now next one, a different interval than we're used to. So this is saying from negative pi over 2 to pi over 2. What the heck does that mean? Well, let's look. This is negative pi over 2. This is 0. This is pi over 2. So we're really only working within this area here. So similarly, I'm going to just copy and paste it over for reference. All right, so, cosine's not by itself, so let's go ahead and divide by 2. We know that cosine of theta equals negative root 3 over 2. Well, again, cosine is negative x. When you have an x value of root 3 over 2, your reference angle will be pi over 6. We also know that x is negative in quadrants 2 and 3. So if we go ahead and draw this in, in quadrant 2 and 3, does that even fall between that interval? No, and there's no way, even if I make them negative, it's just going to reflect into, if I made the angle here negative, so if I made it negative 5 pi over 6, it would just reflect into quadrant 3, so that's not going to solve anything. Therefore, in this situation, there's no solution. All right, now let's check the next one. When something's squared, we want to get rid of that, so we're going to square root both sides. and we get cosecant of theta is equal to plus or minus the square root of 4. Okay, so now I want you to ask yourself, let's think about what is the reciprocal function of cosecant? Well, we know the reciprocal function of cosecant is sine, and that the reciprocal of 2, or plus or minus 2, is plus or minus 1/2. So if we look here, we have to account for 4 different situations now. So we know that when you have a sine of 1/2, this means a reference angle of pi over 6. So if we're looking at the positives, we know that sine is positive in quadrant 1 and 2. So in quadrant 1, and when sine is negative, it's in quadrants 3 and 4. So normally we would say this, but there's an issue. It was supposed to fall between pi over 2 and negative pi over 2. So we're really only looking at this portion of our graph. So is pi over 6 between negative pi over 2 and pi over 2? Yes. So theta could equal pi over 6. However, 11 pi over 6 is not within that interval, but I could rename it to be that. We know that if this is positive pi over 6, if I reflect it over the x-axis, to be negative pi over 6, that is the same location. That also satisfies our interval. So that's a possible solution for theta. All right, and then lastly, tangent. We know that anything that has a tangent, which is y over x, of root 3 has a reference angle of pi over 3, and that in quadrants 2 and 4, you have negative tangent. So let's go ahead and take a look. Again, if I reflect 2 pi over 3 or 4 pi over 3, it's not really changing the quadrant, so that's not going to help us. However, in quadrant 4, this would fall within the interval. We're just going to have to name it differently. So instead of saying 5 pi over 3, we can say, okay, if this is pi over 3, then right here would be negative pi over 3 and would satisfy our interval. So theta could equal negative pi over 3. So hopefully that helped. Now we're going to get into our Pythagorean theorem and sine and cosine. So go ahead really quick, pause the video, see what you can fill in here about sine, cosine, and tangent, and then go ahead and label those sides on the right triangle, because these only hold true when it is a right triangle. All right, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And it all depends on what angle you're referencing from. So notice that it says theta, so that's my vantage point. So if I think, what is opposite of theta, which is here, that is not the hypotenuse, well, opposite of theta is here. The hypotenuse is across from the right angle, so your hypotenuse is there, and then meaning your adjacent side is here. So if we're given triangle ABC and we're given each side length, I want you to say the sine, cosine, and tangent based on the angle BAC. So I want you to look through what's your longest side. My longest side has to be my hypotenuse. And if that's labeled AB, then we know our final side has to be C. So let's go ahead and do our labels. Now, again, it says of BAC. That means that you are looking from the vantage point of A. So go ahead and do your sine, cosine, and tangent for this right triangle. So pause it. All right, so go ahead, check. Did you get those right? So those trig ratios satisfy the sides. Go ahead now and label the triangle for ABC. Notice here I only gave you 2 of the sides, so you're going to have to use Pythagorean theorem to solve for the remaining one to set up your trig ratios. So pause the video and try that. All right, so we're going to have to solve for the adjacent side, so AC. So remember, it's hypotenuse is equal to side squared plus side squared. And the reason we can't have the minus is sides are only positive. You can't have negative distance. So AC will equal 15. Again, it says BAC, so our theta is going to be in that middle letter. And we'll go ahead and you're going to write out your sine, cosine, and tangent for all of those. I'm not going to give you the solution to this, so you can check with your group, or when I collect this, I'll check it. All right, for 3, it gives us a triangle. And it tells us that based on wherever theta is, so let's call this theta, that our cosine, which is adjacent over hypotenuse, is 5 over 13. So our adjacent side is here. Our hypotenuse is here. You can do Pythagorean theorem, or I would hope that your geometry teacher taught you the triples, because this is a Pythagorean triple. If you don't remember them, that's okay. You can still use Pythagorean theorem. And remember, since these are sides of triangles, these have to be positive. So now think about secant. Secant correlates directly with cosine. It's the reciprocal of it. So I already know what cosine is, so I just reciprocate that to say 13 over 5. For sine, go ahead and try that one, and tangent to see what you get. Okay, so we've, in this time, just been reviewing what you learned in geometry and talking about lengths of right triangles in a plane where all sides are positive. As we know, when we start introducing the other quadrants, there are possibilities of having negative values. So if we look here, cosine is equal to negative 3 over 5, and beta is in quadrant 3. So what we're going to do is, we know that this is adjacent over hypotenuse. So let's go ahead and sketch out our triangle. Hypotenuse represents your tangent line. So we know that our adjacent, our x value in quadrant 3 is negative. We know that our hypotenuse will be 5, and we can now solve for this missing side. We know that missing side must also be negative because it's in quadrant 3. So again, you can know your triples because it's a 3, 4, 5. If you don't remember them, you can do Pythagorean theorem. So we're solving for our y. So y squared plus negative 3 squared equals 5 squared. It's going to equal plus or minus 4, but in this situation, we know in quadrant 3 that y is negative. So it'll be negative 4. We can now set up our trig ratios. So secant is the reciprocal of cosine. Again, we already know that. It's negative 5 over 3. Cotangent is x over y. So in this situation, it'll be negative 3 over negative 4, which results in 3 over 4. Now go ahead and write in your sign, and I'll check to see if you got it right. All right, try and work through example 5, see if you can figure it out. Then, so pause the video and come back to check and see if you got it correct. All right, the video should have been paused. You should have tried your best to see how you could do. And now let's check. So cosecant is with sine, and sine is opposite over hypotenuse. So in this case, it'll be hypotenuse over opposite. It's also telling us that our secant is greater than 0. And remember, secant is with cosine, So you need a positive cosine. You have positive cosines in quadrants 1 and 4. And then with cosecant, notice that that was also positive. So you have positive sine in quadrants 1 and 2. So what's the overlap? Oh, they share quadrant 1. So this figure is going to be in quadrant 1. So in quadrant 1, we know our hypotenuse will be root 65. Opposite of beta is 7. And you can now solve for that missing side. We know that in quadrant 1, x is positive, so this will be 4. Go ahead now and do your ratios. All right, now just more practice with finding your 6 trig functions. So it gives us a point passing through, or where the terminal ray is passing through 8, comma, negative 15. So we have a positive x and a negative y. What quadrant would that be in? Quadrant 4. And you can use this to solve for your missing side. All right, hopefully you're still working through. Go ahead, pause the video. Now you'll check your solutions. All right, so if we still have time left, I'd like you to complete examples 7, 8, and 9. When you do finish those, make sure that you turn the notes into the sub. So I want everyone to turn these into the sub for me to check your progress and work. And then you can work on homework A, the backside, to turn it.